Hey, what's up guys, welcome to the third clip about string manipulation in the C# for Beginners playlist. In this video we'll learn some more complex string functionality and tie it all together with two practical programs with application in the real world. One program that notifies us when the price of a product changes or when the product gets back into stock or some concert tickets are put into sale or something like that. And another application that allows us to take bulk data from pretty much any website that allows us to do so. More on that later in this video. Without further delay, let's start with the beginning. What if you have some text and you want to search if it contains some other text? You can use the contains method like this. The explanation is simple. It returns true or false whether the text we are searching for is contained inside the text we are searching into. But be careful, this suffers from the same uppercase or lowercase problem we saw in the previous lesson when we used the equality check. So you have to either precisely type the text you are searching for, or you need to convert both to lowercase or uppercase and do the comparison with the same casing. Another way to see if a text contains another text is to use the method IndexOf and its variations. IndexOf also searches for strings inside other strings, but instead of returning a Boolean result indicating whether the search term was found or not, it returns a numerical index, the position of the first occurrence of the search string inside the text, or -1 if none is found. So we could have something like this. And the first thing to notice is the fact that we are storing the result in an int variable. Again, that's because IndexOf returns a numerical position of the search term inside the text. So let's put a breakpoint and let's analyze them one by one. The first result will be 0. That's because we are searching for this, and this is right at the beginning of the phrase, is the first and the only occurrence inside the text. If multiple occurrences would be found, still we would get the first one, the position of the first one. And because we are searching for multiple characters, we are getting the zero-based position of the first character of the search string. Next, let's talk again about character casing. If we are searching for John with uppercase J, precisely as it appears in the original text, index will have the value 25. There's the position of the first character, J, of the search term inside the text. But if we are searching for John all uppercase letters, index will have the value -1. Again, -1 indicates an error. It didn't find the search term inside the text. That's because, of course, John with all uppercase letters is not the same as John only with J capitalized. But in that case, we can use an overload of the IndexOf method that takes a string comparison as a parameter. Don't worry about that. It's just a way to tell it by ordinal ignore case to ignore any casing differences. So regardless of the fact that we wrote it with all uppercase letters and in the text appears only with J capitalized, just search for it. Ignore any casing differences. And in this case, index is again 25. If you pay attention to the last three searches, you will see there are variations on the same theme. So we are searching for the letter I, but the original text has a lot of occurrences of the letter I. So how are we going to search for the next ones, not just the first one? Because if we are using the regular IndexOf version of the method, we will always get index 2. That's because 0, 1, 2. That's the position of the first occurrence of the letter I. But we can also use an overload of the IndexOf method where we can specify an offset, a position from where the search should start. And we are telling it to start from the position 3, which is 0, 1, 2, 3, so from the letter S onward. And in this case, index will have the value 5, because 0, 1, 2, 3, 4, 5. This is the new position of the searched I. And we can also specify a number of characters to search from this offset position. So from this position, 2 more characters, something like this. As I already mentioned, IndexOf also has variations. LastIndexOf, because sometimes you want to search for stuff at the end of the text, not necessarily at the beginning. And LastIndexOf has the same overloads as the IndexOf method, so you can search starting from an offset for a certain range of characters and so on. Other ways of searching for a string inside another string, this time more specific, are StartsWith and EndsWith. Which, of course, check if a string starts with some string or ends with some string. So, and now since we can search for text inside other text, we can obtain parts of this search text using the Substring method like this. We declare a string method and we put some text inside it. And then we use the substring method to basically say, give me a part of this text starting at offset 11. So the remainder of text starting at index 11. There is a variation of the substring method where we tell it from where to start giving us a substring and how many characters from that index, from that offset. The downside of this example is the fact that we needed to hardcode the offsets. But remember, IndexOf, LastIndexOf and their variations return a numerical index of some search string. So instead of hardcoding these offsets, we can actually obtain them by searching with IndexOf and LastIndexOf like this. And we obtain the same results. Another pretty common operation is to split a string by some common separator character. For example, if you have a paragraph and you want to get the individual sentences, you need to split the original text by the period character. Or maybe you get a list of names and they are separated by comma and you need to get the individual names. You do something like this. And in this case, we initially have a string with the names separated by comma and space, and then we use the split method to split by space, by the character space. And we obtain an array of strings. And then we can iterate that array of strings and you can see the names individually printed on the console. However, as you can see, some of them have a comma afterwards. That's because we use a space character to split the original text, meaning everything that is around spaces is what gets to be placed in the elements of the resulting array. So name plus comma. And in this case, we need to use a different overload of the split method that accepts an array of characters by which to split the original text. And in this case, we do get the name split by both space and comma, but we have a different problem. We have these empty lines between the elements. Why? Because we have comma, space, so two different separators next to each other, and between them we get an empty element. We need to get rid of it, we need to use yet another overload of the split method that removes these empty elements. And now, the names are split correctly. Obviously, if we have a split method, we also have a join one, which is the reverse. Takes an array of strings and merges them together into a single string using a specified separator character. At the end of this lesson, let's also mention two methods that you will probably use a lot: IsNullOrEmpty and IsNullOrWhiteSpace. They both behave almost the same. They return a boolean value indicating whether the text you are giving it to them is either null or empty, and whitespace. Whitespace again is tabs, spaces, enters, all that. So basically these are two methods that help you to determine if the text contains something meaningful to you or not. Now let's address the two sample applications that make use of the string functionality we learned over the span of the last couple of lessons. But before I do that, I need to make something crystal clear. Web scraping can have serious legal implications, so just because you can scrape a website doesn't mean you should. Most websites have terms of service that explicitly prohibit automated data extraction, so violating those terms can get you into legal trouble. Even though we will be using Wikipedia, which allows this kind of educational use under Creative Commons licensing, that doesn't mean the content itself is free of trademark and copyright restrictions, so be careful also about what you are scraping and what you do with it. What we are doing here is purely for educational purposes, to learn string manipulation in C#. So before you do any web scraping, you absolutely must read the terms of service of that website, respect their rate limiting, check their robots.txt file, maybe consider using their API if they provide one, etc. So before we start, I need to reiterate, this is only for educational purposes, is not encouraging you to go scrape any website on the internet, and you are responsible for what you do with what you learn here. So let's start with the application for getting data from pretty much any website. In particular, let's get a description of every episode of every season of the TV show The Simpsons. And for that, first we need to ask the user to enter some URL. And then we need to store whatever the user enters in some variable. But this is error prone, because the user can press enter without typing anything, or whatever they enter could not be a URL, or the URL could not be a Wikipedia one. So basically we need to make some checks to make sure that whatever the user enters is in the format that we are expecting. And that is called validation, and for it we can use a few methods that we learned over the last couple of lessons. Like for example IsNullOrWhiteSpace, which if you remember is the one that checks if a string we are giving it is not empty or composed of white spaces like tabs, spaces, and so on. We can also use the methods contains in combination with toLower to make sure that the text entered by the user contains the word Wikipedia regardless of how they type it, uppercase, lowercase, and so on. So basically we could have something like this. And now, when they enter something that is not okay, they will get an error. But this has two issues. First, this is not how validation of URL should be done. This is just for demonstration purposes to basically know where and when you could use some string functionality. Second, this is not a good user experience because they get an error but the program closes. They basically need to run it again just to try again. So we need to constantly ask the user to enter a URL until whatever they enter is in the format that we are expecting. And basically we can do that with a loop, of course. And now we have an infinite loop that when basically we are escaping out of it only when the user enters something that is okay. And we use the break keyword to break out of it. If not, we are cycling every single time to ask again. So and so on. What follows next is based on stuff we haven't learned yet. Sorry, but I had no choice for this example. First, let's understand what the issue is by going to some website. And maybe you knew already, maybe you didn't, but whatever you see graphically on a web page is dictated by a code like text called HTML, which you can observe by right-clicking anywhere and choosing View Page Source. All the text that you see here is basically what dictates the elements in the page, the order they appear in, and so on. So when we programmatically interact with a website, we need to basically obtain this HTML, this text. And there are many ways to do so, but in C# the preferred way is to use an HTTP client. And for now you can think of it like a Chrome tab, something that accesses a website but not graphically, it's just in memory. But since there are multiple ways to interact with a website, like for example when we ask data from the server to display a web page, or when we are sending data to a server to post a web form, or etc., we need to create what's called an HTTP request, which tells the server what we are trying to do. In our case, we try to get the web page that contains the list of seasons, so that's how we will call our variable too. Not only that, but we need to take the declaration of the URL variable outside of the loop's body. Why? Because if you remember, a variable declared in some block is visible only inside that block and in nested child blocks, not outside of it. And we need to use the URL variable after the loop's body. So we need to take the declaration out. And now we have an HTTP request of type GET, so give us data, at a specified URL, so a specific web page. Now we need to specify what's called a user agent. Don't worry about it, it's not something that concerns you. Just know that without it, most web servers would just reject our request. And now we can make the HTTP request. But HTTP requests can fail sometime. For whatever reason, the server could return an error message or something like that. So we basically need to stop the execution if an error occurs. We have no reason to continue if the server returns an error response. Okay, at this point we made a request to the web server returned a successful response, but this response object is quite a complex one. We don't need it entirely, we only need a property called the content, which is actually the HTML of the web page. So, and now if we put a breakpoint and we run it, we can actually make the HTTP request. Let's grab the URL. And now, would you look at that? This is the HTML of the web page. So let's select it and copy it and paste it in some external editor because we will need it for many other purposes. But if you look at it, the HTML is exactly the same as the one we observed on the web page. So they are identical. Okay, now we got the HTML of the entire web page, but we are only interested in the part that is related to seasons. So if we look on the web page for that section, we will see that it is located in this table, in this release table. So basically they are numbered, where each number is a link to a web page dedicated to that season. So we need to remove the entire web page up until where the numbers start. And the fastest way to do so is to right click the element we are interested in and choose inspect. And this will highlight the portion of the HTML where this element is located inside that HTML. And as you can see, if we expand a few elements here, you can see that the last element that we don't need is this row above where the number season numbers start. So the last element is this episode title, this one right here, TH episode title. That's what we need to search for in our HTML to actually see if it appears more than once. And if we say count, it's only found once in the entire file. This is very good because we can basically use it to know from the beginning of the page how much can we remove from the HTML. We can remove up until and including this TH episode title. So if we actually search for this text in the HTML, you don't have to be an HTML expert to notice some patterns. So we have this table, which is the table in our web page, and then we have tBody, which is the body of the table, tr, which is table row, th, which is table header, td, which is table column. I don't know why it's different in this case, but not only that, you can also see that all elements have an opening element and a closing element. Like for example, opening th, closing th, opening th, closing th, opening tr, closing tr, and so on and so on. So basically we need to remove all the HTML from the beginning of the web page up until where we said that the row where TH episode title appeared is located. So for that we can use two methods, IndexOf and Substring. And if you remember, IndexOf returns the numerical index of the first character of the first occurrence of the search string. So in our case, if we were to search for TH episode title, it would give us the index of the first character, this one right here. But we don't want to remove only up until this point. We want to remove up until this point plus this text plus its closing header and row. So basically we need to say remove up until where IndexOf says the index is located, plus the length of this selection. And if we look here, it says that the length of the selection is 29 characters. So whatever IndexOf returns plus 29. So let's do that. And now if we run it again and we grab the HTML, the beginning season HTML should be starting with a tr, etc, etc, etc. So basically we eliminated all the beginning of the web page up until where we are interested in. So we remove the beginning of the HTML that we don't need. We can also remove the ending that we also don't need. So if we go back to our HTML and we look at some patterns again, if we double click a tr element, we can scroll, 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 and we can see the rows of the seasons. But at some point, we will get to the last row of that table. And we can confirm that by noticing this closing tBody and tTable. So now we can use Substring and IndexOf again, but this time we will not remove from the beginning of the page up until something. We will substring from the beginning of the selection and up until IndexOf returns us the index of closing tBody and tTable. So something like this. Give me the HTML, the substring, starting at the 0 position, the 0 index, and up until you find the index of tBody and table, closing tBody and table. And now, if we grab the URL again, we will only get the HTML portion that we need. And now, since this is only the HTML that contains the table rows that list the seasons, what we need to do next is to take the seasons and split them such that we can iterate each season individually. And for that we can use the split method, which, if you remember, takes an original string and splits it into an array of strings, but in order to do that we need to specify the separator by which to split the original string. And in our case, because each season link resides on a table row, we can use precisely that. We can use a tr to split the original HTML. So we can split by tr and, just to be sure, new line and td, something like that. So something like that. And now we can iterate this array. We could have used a for each loop, but let's use a for loop so we can also get an index of the iterated season. So if I put a breakpoint and I restart the application, we get an array of seasons, 37 to be more exact, plus the iterated season, which if we inspect, we can see that we still have a lot of extra data that we need to filter out. If we look on the original page, we already know that the only thing that interests us on each row is the first column. That's where the link towards the season page is located. And if we inspect it, in HTML, a link to another page is created with this href and closing a. And the link itself is between the quotation marks. So in our HTML, we need to substring again and use IndexOf to remove up until this first quotation mark. And remember, again, IndexOf returns the index of the first character of the first, so on, so on. So basically we need to IndexOf to this plus the length of this selection, so 9 characters. So coming back to our code, now we basically substring up until this point. Now we need to grab all the string up until the first quotation marks that follow. But there is another issue. Here we have /wiki. If something starts with a slash, that means it's a relative URL, meaning it's not the entire URL, it's relative to the current location of the web page. And in our case, it would be relative to en.wikipedia.org.wiki, etc., etc., etc. So basically, we need, in order to create the entire link, we need to add to this also the base address, and so on and so on. And now if I run it again, we should get for season link only the link towards that season. If we copy it and we open it in a browser page, we get the web page for that season. Yeah, Wikipedia. Let me pause my tutorial to donate to you. So now we have the list of season links and we can iterate them. We did programmatically what we would manually do if we would open these season links in new browser tabs. What we need to do now is just the same thing all over again. This time is for the episodes. We need to scroll the web page of a season to see where the episodes start, and we can see they start at this section called episodes. So we need to grab the HTML of each season page to substring to that section. So we basically need to do the precise thing we've done before, but now it's not for the TV show page, it's for each individual season page. And now if I set a breakpoint here and I run it again, I will get the HTML of the episodes of the first season. And we can copy this, paste it again in an external editor, let's also change the highlighting. And now we have the HTML of the page that contains the episodes list. Now that we have the HTML of the season page, we can go to that web page and we can look for stuff that we can remove at the beginning and at the end of the web page. And a good starting point is to inspect something that is close to the table that lists the episodes. And we can see that we have table right under. If we expand it, we have tbody, the body of the table. Then we have a row, but this one is the header row. Then we have two style elements. We also don't need those two. We need to eliminate them. So let's search in our HTML for this particular section. So it's see also. Let's see if we have more than one occurrence, and we don't, we have only one, because if we have more than one occurrence, we can substring to the wrong one and we are in trouble. So let's look around. We have the table starting right under, then we have the closing style element that we saw there, and let's see if this, for example, border bottom dotted 1 pixel, etc., is found more than once. No. There is only one occurrence, so this is a good point to substring to. So let's copy it, let's get back to our code, let's stop it, and let's see the length of the selection, because again IndexOf returns the numerical index of the first character, not of the selection itself. So basically we could take this selection of 34 characters, but let's also include the new line character. So if we include that one, because this is Windows, we have 36 characters. So Now we need to remove the bottom of the page, but we already know how to do that. We need to search for the closing tbody and table. And now if we run it and we grab the URL again, we have only the HTML piece that contains the list of episodes. So let's paste that one. Now that we have the HTML containing the list of episodes, we need to split them so we can iterate each episode individually. And just like we did for the seasons, we can split by the table row. So this is a good starting point, but I think this time we can select a bigger chunk. Let's try this one and see if it's unique. And we have 12 matches. Let's confirm that there are 12 episodes in the first season of The Simpsons. And we have 13, okay. Let's see what's wrong. Oh, we substringed an extra character, so if we hit count again, we have 13 matches. So we substringed an extra character there. So this is a good separator to split by. And if we split the episode's HTML, we can also iterate the resulting array. And if I set a breakpoint, now we should have an array of, but let me first grab the original URL. So again, we should have 13 episodes, and we do. And we should also have the currently iterated episode. Let's inspect it, this one too. And again, we have a ton of extra information which we need to filter out, just like we did for the seasons. But it's quite easy to see that we have an href here, which is probably the first link in the table row, the first column that contains a link, and this is the one we need to substring to, so we can navigate to the page of the episode. So again, we need to substring to the first occurrence of href plus 9 characters. If you remember, the offset is 9 characters. So and if we drag the execution and rerun these, we can see that episode link is indeed a link towards some Wikipedia page. Let's open in some tab to confirm that indeed it's Wikipedia page for the first episode, Simpson roasting on the open fire. And the first episode is Simpson roasting on the open fire. And now we have the list of episode links, which we can use to navigate to the episode pages. So let's start the execution and do that now. And if we set a breakpoint again, we are in the possession of the HTML of the first episode. So let's paste that one too. And now all the thing that remains to do is to go on the episode page and see where the description starts. And we can see that we have a section called plot. So everything is all over again, just like we had the list of seasons, the list of episodes. Now we have a section for the plot. We need to substring to it. If we inspect the plot section, just like we did before, we can see that we have an H2 header to it's the size of the subsection, the text. H2 ID plot with plot between. So let's substring to that. And we eliminated the beginning of the page up until the plot section, but we are just we just got closer is not actually the entire story. So we still need to substring to something else, because the description starts at this paragraph right here. So we still need to eliminate basically all this section from the plot up until the first paragraph, all this span stuff and div and etc. The reason why we didn't substring directly for the paragraph or the P element is that the page, as you can see, contains more than one P element, including before the plot. So if we would have said something like substring for the index of P element, we would have gotten the first one in the page, not necessarily the one we wanted. So in the case where the element that you want to search for appears multiple times, first substring to something that is closest to it, that is unique but is closest to it, and then substring again from the resulting substring to the element that you want. So let's do that. Let's substring to the first paragraph. And if we run it again, indeed it starts at the first paragraph, but we still need to eliminate whatever comes after the plot section. So if we inspect it a bit, we have the first paragraph, the second one, and probably the third. Yes, 3 paragraphs make up the plot section, and whatever comes after it is the beginning of the development section. So we need to substring up until to the div. And if we run that one too, we should have only the 3 paragraphs, and we do, which means now we can actually display the description of each episode of each season. Let's not output the entire description, because this one has 3 paragraphs and that's quite long, and others could have more. Let's output only the first 100 characters, and if we run it and we get the link, and we get an exception. Oh, 429, too many requests. So that's why, kids, you should not scrape websites, because some of them might protect against it. Like, for example, limiting you how many requests you can make per second. I am surprised that Wikipedia does. Anyway, if we look at the console, we can still see that indeed we have a description, the first 100 characters of the description. So basically, we still have HTML elements like the P element or the href, and you'd have to eliminate those, but you do have the description, and you can output, you can do whatever with it. In regards to the exception, what you could do, you could try basically to set a pause each iteration of the episode, so the program doesn't make the request so fast, something like this. Don't worry about it. Task.delay is just a way to pause the execution for this specified amount of milliseconds. So 1000 milliseconds, 1 second. But this is not the scope of this video. So we are done with this example. Let's jump to the next one. Let's make the application that constantly checks if the price of some product has changed, or if the product is back into stock, or whatever. So there is nothing that you haven't seen before here. We are asking the user to enter some URL. We are no longer making the validations because you already know how to do so. And this is just an example. And basically we create an HTTP client, which we use to send an HTTP request, and we get an HTTP response. And from that we read the content and display whatever. So the way this is supposed to work is quite simple. We ask the user for some URL, we get the HTML of the web page at that URL, and we store it in some string variable. Then we need to constantly check some predefined interval, 3 minutes, 5 minutes, etc. We need to grab the HTML of that web page again and compare it with the one stored in the original string variable. If they are the same, nothing changed on the HTML page. If they differ, something changed on that web page, and like for example, if you change the price of a product, that changes the HTML. So this is a very rudimentary way of making sure that something changed on the web page, but it works. So we have an infinite loop, and we have a way to pause, just like we saw in the previous example, every, I don't know, 5 seconds. Now we need to grab the HTML of the web page again and compare it with the one stored. Not only that, but if they differ, we want to store the new HTML in the original HTML, because otherwise they would differ the next time the loop cycles, and so on and so on. So you would get this message printed every single iteration. You need to update the original HTML when the new one changes, such that the next cycle it's updated and they are not different. And when it's changed again, it's again detected, and so on and so on. So I don't have a website that I know of to have the content change every 5 seconds, but you'll have to take my word for it. This would work. Again, this is very brittle. For example, if the web page has some countdown timer on it for Black Friday, or a clock, or something that changes the HTML every second, this is pretty much useless, unless you start substringing and comparing precisely only the HTML part that you are interested in, like for example the paragraph that displays the price, instead of comparing the entire web page. Anyway, again, this was not intended for you to make illegal stuff on the internet. It was just a demonstration of how important it is to know how to manipulate text, because again, the vast majority of application you'll be doing will manipulate text in one form or another. So if the purpose of teaching you that was achieved, consider dropping a like and maybe subscribing too. In the next lesson, we will talk about nullability and why it has become such an important topic in recent years. Thanks for watching, and I'll see you in the next tech frame.